numbers. There are multiple talks, including me on that topic, on how to tune it, right? But you must remember that your defaults depend on your environment. They depend on your actual resources on the pod, right? That may really change your garbage collector, for example. This is the most famous example. You fall back from G1 to serial GC. If you just use default options in your containers. And who sets options for their containers? Yeah, that's fair. I believe it. Like that's not the real problem. That's the situation. That's fine. They don't break. If we don't set options, they don't break. Well, we somehow can make it more effective. We can improve the performance, and we can get really different numbers from kind of even trivial applications. I'll just show some example, and you can do the very same with your own service. Well, what happens with our containers in Kubernetes? We declare some deployment, and our container images are somehow started somewhere. But we have to control what resources we can provide for that running pods, what options we should choose for the JVM. We can tune it when we start the application, or we can tune it in advance, but we can do it. We can do both. Sometimes we have options. For services that are not so important, we can say, okay, they really need that amount of memory, but they run okay if it's lower, right? So there are different so-called quality of service settings when we regulate requests and limits for our pods. But please remember that setting your memory requirement lower than your actual extra max is a very bad idea. So my favorite second story here is from a bank, European bank, and you guys called us and said, we have a problem with container response. Our deployment is constantly down, and we have the startup problem, which isn't really a startup problem for a single service. It's not a thing to start for 8 or 30 seconds and then warm up. But it happens constantly, so now it's a problem. And their startups were caused by setting their limits lower than XMX. They said, okay, it works for some time. Right, it works, and then the memory consumption reaches the limit, and bang, your service is down. Not fun. Even more interesting situation. Days like Black Friday, when you need to scale, and sometimes you already have created all your nice fleet of microservices and whatever, like the company that I mentioned in the first study. And then they have exactly Black Friday, and they needed to sell a lot. And if you prepare for such scaling in advance, they try to prepare. Some probably trivial lessons, like don't try to rely on the pods that won't be available to you, right? Rely on real ones. Split the services. Some of them need to be very accessible, some are not, right? That's the question of SLOs. And you have to plan in advance to create scaling strategy, because if you scale enormously large, you pay enormously large. And probably the cloud providers will cover your scaling, say, okay, we have the budget, we scale for all the budget, no problem. We will satisfy all the requests, but it will be too expensive. So you have to limit how much you scale, you have to prepare strategy. Sometimes you need to scale in advance or create steps, right, to scale slightly in advance. And then you have to scale down. In the very best scenario to 0. That's why we did lambdas, right, to scale to 0. It all should be controlled by monitoring, right? That's one of SLO's and indicators that we have, how much do we spend on the cloud. And here, such solutions that provide you information about cloud spendings, they can be useful here. When we scale, we have limitations. If we try to scale some service, obviously, we depend on its dependencies. If the database is used by a service and it only is able to satisfy 500 requests per second, you won't get more than 500 from this service if every request requires a database query, right? And the real situation, yes, sometimes we underutilize resources such as databases that can be co-located for different services. Meanwhile, pods still break after all of that. And we'll see their performance characteristics. Let's talk about the favorite application of all Spring Boot talks, all Spring talks, Spring Boot pet cleaning, whose application is like that. So you don't use Spring here, or do you? Yes, some people use Spring and Spring Boot. And this application, in its different versions, is different. So you know probably that Spring Boot has now version 3.3 actually, and it supports nice optimizations like creating native images or Spring AUT in general, where you can lower the overhead of using such sophisticated reflection-oriented CDI framework like Spring. Well, and version 2.7, which is older, but it is still great and widely used. And applications that are based on 2.7x typically run on Java 8 and 11. That's not necessarily, but it happens. Anyway, we'll create some container from this application.
Yeah.
There are many ways to do it, to containerize a Spring application. And this survey is also a few years old, I think, and it's still true, very true. We expected that the ratio for build packs will raise. It doesn't. And now we know why, by the way, but that's a different story. So there are more or less complex ways to pack your resulting build into a container. And they are all correct. But sometimes they all seem complex, too complex. And our cloud providers typically say, please bring your applications to our cloud. Here are some tools to help you. But these tools are not magic tools to containerize your application, because they only help you to struggle with the boilerplate of cloud vendor settings. They don't create right Java options for your container because they know nothing about your application. They somehow just try to replicate your previous environment in that new containerized unknown jungle. But it's simple to create your own container, right? And it will be quite effective. But even in this simple situation, we have to plan our resources in very advance. Like you see here, we set run percentage. That means we know, or we have tested, that for some sizes of pods we plan to run on, this value works correctly, so it doesn't break at least. And why do we set it here? Because we want to use that resources. We don't want to use only a quarter of your memory, right? Because if you put nothing, you will only use 25% of your pod's memory for your Java people, which works badly, of course, with gRPC because automated garbage collection requires extra memory to work fast. Well, other means of solving the same problem, making your application a container, is build packs. You can run them standalone, or you can use standard Maven and Gradle commands to build your container. And if you build such container using the standard Spring Boot way of building the containers, you will get some optimized things in there. You will have extra options. You will have not Alpakita, but somehow prepared and updated Linux. You will have the Berkeley JDK inside, by the way, because we are the default JDK provider for Spring Boot. And if you create native images, it will use the Berkeley native image kit to compile the native image. And build packs are great because you need nothing. Nothing but Docker. All things Docker and base Java to run, maybe not Gradle. Right? Even that can be downloaded if you use wrapper script. Inside, under the hood, it will download different containers, some code stack, to build your application. Like you can run your build on JDK 17, but build for JDK 21, and it will be automatically downloaded somewhere with a build container in a reproducible environment. And another part of the stack will be run stack, where you will just have very slim Linux and only things necessary to run your application. But also, you will have a starter script, which will look at your environment before starting your Java application, before starting the JVM, and will add some wise options. I could say, oh, hey, okay, we have some right settings set, like the number of Tomcat threads, etc., and we'll calculate how much memory we can use for the Java application, besides reserved memory. So to provide the best possible performance for this container. But we'll also add diagnostic flags. So when the application or pod exits, you can see, okay, that much memory has been used for native buffers or whatever. So you can tune that meaningful settings and create even better container. Some settings are listed here. You can provide any Java options you would like, right? But some of them will be created based on your settings. There are some defaults, and all that can be overloaded. So in the end, we have that set of containers. We have builders as separate images. We have base images. We have resulting images. And here are some with native image, with JVM, and two lower ones are built with build packs. And the upper one is the base one for the manual Docker file image that I've shown previously. Anyway, you can create very small containers, 100 megabytes, right, or 150 with your application. It's not a problem nowadays. Just think about that and build your CI/CD pipeline so it would create an effective one. So you can not spend your network traffic, disk storage, operating system memory, well, to use it effectively. So we came to the idea of optimizing containers, right? Before optimizing applications. We don't have to change the code, but we can make them work better just by providing wise settings. Just when we think a little about it, it's not that hard. So let's create some performance testing environment. You can use any tools you like. And in companies, that to me that's obvious, there must be a performance management process somehow built just to use your process for your real business purposes. So we can harness, we can load the cluster, and inside the cluster, let's choose the right size of the pod. So assume we have some resources, hardware resources, or there's a bare metal server in this case, and we can divide them by using different deployment settings. And it's easy to achieve in Kubernetes. But I selected some possible sizes of pods, just because, in this case, Amazon gives those sizes for autoscaling. So you don't have to test everything with a step of 1 megabyte. You only should care about real possible port sizes. And let's say our application must respond under 100 milliseconds, so it's business critical. And these new numbers with the release Spring Boot say, okay, we can actually run it standalone, without any containers, without anything. On this bare metal instance, just limiting its memory. And we must check that, because numbers differ. Either you run in your container environment and they really can shift your numbers, making them lower, of course. And we can actually vertically scale our application, but it requires careful tuning of JVM options. Because with this application, and not just JVM options. For example, for the older version, we have to tune all the Tomcat threads. We have to select our garbage collector, especially for very large heaps, right? If we have 100 instances, each running in 100 megabyte heap, that's simple, right? If we have or 1,000 with 1,000, not that complex, or each of them. But if we have one instance running with a terabyte heap, we have to tune our JVM options, especially if we don't have ZGC, right? So this application can be also represented as a native image, which in current experiments show lower numbers than classical JVM with WarpMap. Well, previously it was the reverse, so you have to check. And we are going to walk that simple way, to look at horizontal scaling, to fulfill more requests, like we prepare for the Black Friday. That's the setting. And for the latency requirement, yeah, there's always a distribution of latencies by percentiles. But this is the good picture, the picture after the warm-up. So we already somehow warmed up our application because classical JVM has not that good latency at the very start. But by the way, there's a tool to avoid that, to struggle with latency at the start. And how is it called? Crack, yes. I expected native image, right? Because that's the second one here. Yeah, it's also about the latency part. Yes, we can use Crack with modern JDKs and modern Spring Boot versions that support coordinated checkpoint and restore in user space. Well, and by the way, we provide such builds for JDK 17 and 21, so you can try them like right now. Because we not just provide JDK builds, but also we provide ready-made containers, so you can easily run your checkpoint, run the restore, and try an experiment. So we can put the same single instance inside Docker, containerize it. Wow, same performance. Surprise. Half a year ago, different numbers. They were lower, now it's okay. Let's put it not just in the container, but put it inside the Kubernetes cluster, put an ingress there, and see what happens. Okay, about the same performance. Not exactly the same, by the way, but surprisingly close. So, let's try to chop it and to use more resources. Because we are for horizontal scaling, to say, we still have some resources, but with default settings, the application doesn't scale anymore. So let's use the resources for horizontal scaling. So what do you expect? Is it better or worse? Well, worse. Wow, it's better. Yeah. In some previous experiments, such scaling could make it worse. And in your case, it can make it worse. But you have to measure. No good expectation here. You can only try this. But it's measurable, right? It's the same load testing as for the single application. We just probably changed the address, but we, in any case, are going to deploy it in a cluster. We're going to perform some stress testing or whatever. So let's continue and create more but smaller pods. What's the expectation? Better. Yes, it is better. But we immediately start seeing slower startups for the cluster. So we lowered, especially lower CPU resources for our pods, and it means much slower startup. So here again, Craig will help us to just bypass this slow problem. Well, with the scale, and we can go on the territory that many people start from, saying, please use the most cheap instances, the cheapest ones. You're only allowed to use super cheap instances without additional permission. Okay, development says. Half of CPU for the JVM, which is multi-threaded in any case. No RPS. I, as a developer, wasn't able to wait for the cluster to start. No way for me. It's just, not applicable here. But I would say the performance would be worse here. The overall performance will be worse because of worse compilation quality, right? We have longer compilation queues with lower CPU amount, etc. And we can scale native image case in the same way. But again, we'll have comparable but lower numbers here. Yeah, they do scale. So please don't forget about all the rest good practices related to your Kubernetes deployments. Do the same for your performance. Try what happens in production. Try it before you go to production. Go to production with some partial deployments if you can, right? To see what happens with their health, what happens with their indicators, and what will happen with SLOs, right? And our business goals in the end. We have to care about our JVM service. That's the only way. We just should not leave them empty. Somewhere must be written something. We can work out better container images. It's very simple. We can use build packs and tune only few very understandable settings to effectively utilize our resources. Simple. There are useful flags to tune your containers, to tune a JVM, which you can do either switch on and off or regulate. Yeah, of course, it's well documented. Your applications must be monitored, that's obvious, and use that monitoring results to improve your performance quality, to improve your stability, to improve your costs, to have better scaling. Some other useful techniques also can be applied. We also have a nice blog with articles related to Kubernetes and other stuff. I hope a technical one. So just try it out. I'm not sure about the time.
We have plenty.
We have plenty of time.
Plenty.
Okay. So please ask your questions because we are here to discuss this material, not to say that I'm the single source of truth. You can argue, and I would love you to argue, saying this is totally wrong, we do it differently, and we are right. So please share your experience.
Yeah, I was asking if you can share which kind of options are you or tools are you using for, let's say, measuring the results on the backend side, no? Because at least you have many, let's say, pieces. No? You have the CPU of the pods, you have the memory of something, you have the JVM behavior, you have disk space or whatever. So
for me, it's a simple question. Because yes, I am a JDK engineer, so I can say, yeah, whatever JDK gives me, right? JVM creates logs, so I can enable logs and look like that. what should you use or will you use for your production, for a real system, right? That's the tough question. But we are in a very good position because we work in the most developed ecosystem ever, in Java ecosystem, which means we have ready-made JMX, metrics, JFR, APMs based on that, like Datadog and others. And for some of our products, like Performance Edition, which is a combination of a newer JVM and kind of older JDK. I mentioned complexities with JDK 8, and that's the way to avoid them. And it provides that all new settings, so you can get more information from your older deployments. And I believe like JFR works slightly better now. So you can diagnose your applications. There's a second part. Here it is some load testing solution, right? I just take command line tools with text output, and I'm happy because I can use shell scripts to process what they give to me. But that's not a way, for the big scale. Of course, you need graphical representation, and even that can be made graphical. The part for monitoring or APMs can be used to observe what happens with your JVM in such load testing scenario. It really works, and we show it for the things that we show as possible improvements with the time. And the graphical part of the load testing itself is also useful. So you can observe what happens with response times, what happens with statistics. Sometimes, right in your cluster, there are plugins for JMeter, for Gatling. There's K6 that you can plug right into your Kubernetes cluster. Captain has something for that.
Yep.
Or is it a complete answer? Sort of.
I was just knowing what kind of tools you normally use just to understand, for example, because one thing is running, I don't know, some executions, no, with this approach, and then another one, and then let's say, because then you have to compare, no?
So see here the interesting part. It's hidden here in the lower part of the screen. It says, please unlock some diagnostic VM options. Diagnostic VM options. And we really need them for diagnostics. Please tell me a native memory tracking summary, which will print when the application exits how native memory was used by the application. And native memory is something besides heap that we need to allocate inside our pod, for our running container. Which means if we have 1 gigabyte for the pod, we will spend 128 megabytes for what? For the kubelet, because it runs on Kubernetes. We will spend some memory for our native needs, for our native buffers. If it's, I don't know, Netty or Tomcat with certain configuration, we will use native buffers or we'll use them manually. And that's not counted for our Java heap, right? Let's assume it's, I don't know, 100 megabytes. That's almost 300, right? We also spend some native memory for, you see what? What is here? XSS 1 megabyte. For stacks, because we do use real operating system threads, and they require to allocate some memory, native memory for each of them. Like each of your HTTP executor requires a native memory to just run as a thread, like 1 megabyte in this example. So we have to subtract all that numbers from the amount of memory available for the pod, which will probably leave, if you calculate it correctly, right, only a half of the memory, which is great. let's say we have 1 gigabyte port and we'll have 512 megabytes as XMX setting, or it probably will be around not 50 but 75, 80%, as I mentioned previously, right, for the Docker container configuration, which is way much better than 25%. So you will see your GC poses on your monitor. Easy.
No, that's a question.
Yes, I have a question. What's your recommendation about the memory requests and memory limits? Let's suppose that Kubernetes node is on pressure, and then if it's at different numbers, the application can have memory issues.
Yeah, definitely. That's what I mentioned. For less critical services, right? Just say that your request should be lower. See, okay, I'm fine with running with lower memory because it's not too critical. Let's say latency would be worse, but you have to test it for all possible combinations. Saying in the worst situation, I will get that amount of memory. And yes, elastic settings or such things that determine your available memory in runtime help you. If you just put default settings, that also helps you because it says, okay, we'll use 25% of your memory. It will just work not so great. But if the service is critical, right, you have no other option but to set your requests equal to your limits.
But should we set the same numbers for requests and limits, or what?
Yeah, for the critical services.
Yeah.
And something that many people also do is using different requests and limits on their staging and their product. Saying, we will save. No, you won't, because you will save some money during development, but you will have an effective production. What's the saving here? Yeah, the same happens with the software as a services that try to calculate the lower costs, because you have to deploy them on stage 2, and that's the same story.
Thank you.
Hablamos de garbage collector.
Yeah. What about garbage collector?
Any recommendations for this?
Now it's simple.
It
It started to be very simple. We just discussed our very latest results for performance edition for measurements. So where do we bring benefits? And I said it, and I couldn't believe my own words. Like nobody uses parallel GC. And it is so true now. We still greatly recommend that for any, batch workloads. If you have batch workload, fixed amount of work, and you just need the lowest time, and you don't care about any real-time responses from your application, you take parallel GC. If you have, yes, that's a tricky part of the question. For which JVM? Yes, because if you use a native image, simply using the community edition provided as is will give you only one garbage collection, so you don't have to choose. It's serial GC, which is good for one CPU situation or 2 CPUs, so half of the CPU. But we have implemented parallel GC for the native image for Substrate VM. So if you use the Berkeley native image kit, you can create it's a build time setting. You can embed a parallel GC there. So you can have better performance, and it really works, gives really much more fluid experience, interactive experience with applications. Mostly, we can use G1 GC with only one flag, sometimes provided like the target for the post. If targeting pause is not enough for modern JVMs. It means that you're in a really complex situation. So because there are many flags you can tune, you start with I hope and go further and further, but it is tricky. And likely you will have to switch, or likely you will have to add memory, because that's the simple answer for any GC question, just throw more memory to your application. If you throw too much memory, it's starting to be a problem, because working with large heaps is not so trivial. But now we have Shenandoah and ZGC, have generational ZGC, which allows you to have low pauses without throwing too much memory into your application. And that allows you to have very low pauses, still the same super low pauses with extremely large heaps. So I would say no sense now to use non-generational ZGC, just use generational one. Use G1. Still, you can use serial if you only have one CPU. It won't make it worse. Yeah.
This process is to find out the correct path meters for or the correct settings for your application and to run on Kubernetes, right? But how would you jump then to autoscale? How does these measurements affect to how you configure autoscaling, or do you have any preferred way of configuring autoscaling? What metrics do you use, and how do they relate to the results you may observe from this performance?
Well, thank you. Great question. This is a simple experiment, right? Because it is very tricky. I'll just show you that hexagons. Where did I show them? Cubes. We have that many cubes, and that's it. Simple. But in real world, we have some interconnection between, we have mathematically set some clusters, right? We have same service with some replicas, and there are interoperations between them. There are databases, whatever external systems we can imagine, Kafka, etc. So we are in a situation of the classical task of resource planning, where we should calculate the necessary scaling based on the performance of the individual replicas. So we should calculate some other things besides of what I showed here. So what we have calculated here is the performance of one individual replica running with other replicas alone. So let's say we have 20K RPS and we have 4 instances. We can say, okay, if we use such settings for our JVMs, and if we use this sizing for pods, each replica will give us approximately 5K RPS, which means, yes, we can plan our scaling based on that. That's not entirely true, right? If we have a more complex system, which have many components, we have to determine some values that respond for the interconnection. So to solve the entire capacity planning equation. This is a classical task, and I only show you just a simple part of it. But it's not that complex to calculate the other part as well. Yeah, thank you, great question. I'm talking about simple things, but you're asking about the complex ones.
But also, what thresholds do you think are reasonable? Or I mean, if you find some numbers that work well, how far beyond these numbers you need to go before triggering scaling, or is there any like general, but it's per case, I guess. Right?
Well, we should test it as far as we can go. Of course, sometimes it's impossible to test the full scaling before it happens because it might be too expensive. Maybe it's not too expensive. Sometimes you can just run, okay, let's study our own production before the real scaling happens and let's test it.
Yeah.
So this is about selecting options. And finally, we can project the scaling or we can really try it.
Okay, one more question. Any question?
Some
If not, thanks, Dimitri, for presentation.